So hey nerds, this is Suman and this is going to be our today's integral, that is e raised to ax sine of bx, and that is dx. So you might wonder that you can use integration of by parts formula like u and v, right? And you get is a new formula, that is u integration of v dx minus integral du over dx integration v dx and whole dx, something like that. It would be an integration by parts. But I would like to share you some very much interesting idea, very much interesting formula that I had learned during the course. So basically, you don't have to remember that formula, rather you have to remember this formula. Integral uv can be not dv, integral u dv can be written as uv, the product of uv minus integral v du, right? And this is going to be our new formula. So in terms of here, we have to separate our formula on the basis of what is going to be our u and what is going to be our dv. So for me, u is going to be my sine, and look here, the sine dx, and in terms of dv, the whole this term is going to be my dv. So dv is e to the ax dx, right? And in order to put it into the formula, I have to calculate u and v. I have u here, but in order to calculate v, I have to integrate it, right? Integrate it. So whenever I'm going to integrate, I get v, and I get e to the ax by a. Whatever would be in the coefficient of x, it would be under the diameter of the same function. So I get v, I get u, and lastly I have to calculate du. So du is going to be b cosine of bx, and that is going to be my dx. So I have to arrange all these formats like u, that is 1 over a sine bx e to the ax minus integral, and I have v is e to the ax over a into, and I have du is b cos bx, and that is dx. So I would like to rearrange this formula, that is 1 by a sine bx e to the ax minus, and I get b over a here, and integral e to the ax cosine of bx and dx. So up to here I think it's quite easy. So I get this part. After we get an integral, use this formula, and for the second case we are going to again use the same formula. So for the second case, u is going to be my cosine of bx, right? And du is going to be my, if I differentiate it, I get minus b sine of bx, and dv is going to be my e to the ax dx, and I want to get v, so I have to integrate e to the ax dx, so I get e to the ax by a. So I'm not using integration constant because we get integration constant at the end, so we don't have to worry about that. So now we have to rearrange our equation. So I get 1 over a sine of bx e to the ax, right, minus b over a. So in case of here, I have to write the product of uv. The product is going to be 1 over a e to the ax into cosine of bx, right? And this is going to be minus integral v. V is going to be my e to the ax over a into, and du is going to be my minus b sine of bx. So this minus and this minus would make our integral positive, right? So this minus and this minus is going to make our, you can actually see from here, du is our minus sign, so we get here plus if we remove this negative sign, right? So if you look at this, I would like to make another thing here, that is sine bx e to the ax minus, so I get b over a squared e to the ax cosine of bx, and I get plus minus, and that is b squared over a squared integral e to the ax sine bx, and Oh, sorry, I forgot. We have sine bx and here we have dx. The best part of doing math is you have to remember, identify your problems where you have done mistakes, right? So this would be my b sine dx. So you can actually see this term e to the ax sine bx dx is just our I. So in terms of whole writing this equation, I can write it as I, right? And if I take this over here, I get I plus b squared over a squared. I is, so now if I take e to the ax common from each side, so I would like to make here a square, so does I have to put a in up, so I get a sine bx minus b cosine of bx is common, so not common but e to the ax is common, and it is divided by a squared, right? And from here you can take common I, and you get a squared plus b squared over a squared. I is a sine bx, a of sine bx minus b of cos bx e to the ax whole divided by a squared. So your a squared and a squared term is going to be cancelled out, and you finally left I is 1 over a squared plus b squared, and this is a sine of bx minus b of cos bx, and it is e to the ax with some constant c. So at the end we found that integral e to the ax sine bx dx is going to be our 1 over a squared plus b squared, right? And e to the ax, and we got in bracket term we get a sine bx minus b cos bx plus some constant c. So this is one of the hardest problem, not so tough problem, but it is quite similar. It is hardest problem once you have understand this concept and manipulated what we have, why we have written I here, because I is same as this thing, so you can write I. So and after substituting we got our desired result. So up to there, bye bye, and try to send your problems here